Okay, so the next part of the lab, we actually will add a filter, right? So from the mixer we add a filter in series, yeah, okay, by adding a jumper cable here, okay, and then we monitor the output of the filter with the SA, and here there is a jumper, yeah, that's already there, 818, okay, yeah, so we added in basically this bandpass filter, okay, and actually in this lab we want to find out the effect of this filter. What is it doing? Yeah, what is that filter doing? Yeah, okay, yeah, and therefore we make some measurements. Yeah, okay, so let's have a look at the setup. So here is our setup, yeah, just like in the diagram. Okay, we've added a jumper cable to add in this filter, right? Can you see it clearly? Let me go a bit nearer. So that is the filter, yeah, jumper cable, and we're monitoring the output of the filter here. Okay, that's the output of the filter. All the rest is the same as before. Yeah. And let's look at the spectrum analyzer. So this is actually one of the outputs after the filter. This is actually 868, the wanted signal. Okay, so it is the level, and then let's have a look at the other frequencies. Let's look at 818 megahertz. 818 megahertz. We can't really see, so what we do is we might have to reduce the span. Okay, reduce the span, and we might have to change the attenuation as well. Okay. Is at 818. Okay, it's quite hard to see. It's a very small peak there. Okay, very small peak. Yeah, at 818. Then we have at 768. Okay, that's almost at the noise floor. Okay, and then if you look at 918 megahertz, also noise floor. Okay, so here we already summarized our measurements, okay, in a table, and you can see here these are some of the results that we got. So this was before the filter. We obtained measurements, and then after that we added in the filter, and these are the measurements. Some of them are noise floor, yeah, so we are not able to measure it. Okay, so based on this data, right, I want you to actually calculate the filter rejection, right, which is basically the difference between these two. Yeah, okay, for example, yeah, at 818 minus 9 dBm after the filter is minus 63, so there's a drop in value from this to this value, and that drop is actually the rejection. Yeah, it's the difference between these two values. Okay, so you can actually proceed to fill up. And for here, noise floor would be below the peak. Is actually below minus 80, so the rejection will be greater than a certain number, than this difference. Okay, so proceed to fill up that, and also calculate what is the insertion loss at 868, which is the difference between these two. Okay, and proceed to answer these two questions. What is the main role of the filter, and what would be the ideal frequency response of such a filter? Yeah, so what is this filter doing? Yeah, based on these results. Okay, yeah, so we'll give you some time to do that.